Hey everyone, welcome back to our channel. Today we're diving into the fascinating world of rock durability with a hands-on demonstration of the Slake durability test, a key method in geotechnical and geological engineering. Stay tuned to see rocks tested to their limits. The Slake durability test helps determine the resistance of rock to weakening and disintegration when exposed to cycles of wetting and drying. It's commonly used to assess shale, mudstone, and other argillaceous rocks for use in construction and slope stability projects. For this test, you'll need 2 wire mesh drums, dry rock samples weighing between 40 to 60 grams each, a drying oven, a water tank with a rotation system, and a balance for weighing. First, select 10 rock pieces weighing between 40 to 60 grams each. Dry these in an oven at 105 degrees Celsius for at least 16 hours. Once cooled to room temperature, weigh and record the mass. This is your initial dry mass, labeled M1. Next, place the rocks in the mesh drum and submerge it in water. Rotate the drum at 20 revolutions per minute for 10 minutes. After this, remove the drum and dry the samples in the oven again for another 16 hours. Once cooled, weigh and record the new mass. This is labeled M2. To perform a second cycle, repeat the wetting and drying process just like the first time. After the second drying, record the mass again. This is labeled M3. Now let's calculate the Slake Durability Index. For one cycle, use the formula SDI equals M2 divided by M1 multiplied by 100%. For 2 cycles, SDI2 equals M3 divided by M1 multiplied by 100%. A higher SDI means greater rock durability, and that's how you perform the Slake durability test. It's a simple but essential method for understanding rock behavior in real-world conditions. If you found this helpful, give this video a like, subscribe for more geotechnical content, and leave an